Hi everyone, we'll be presenting on our project called Process Visualization. My name is Schwan.
And my name is Marty Place.
Hello, my name's Chris.
Hello, my name is Yijiang.
First, we'll give a quick overview of the project. Our sponsor Unilever is an international consumer goods company. Many of its products are liquid-based items produced in large mixing tanks like the one pictured. In order to manufacture a given product, one of thousands of potential tanks must be chosen for the procedure. To determine if a tank is compatible with a recipe, there must be no complications between the liquid and the mixing components. This can be difficult to predict since you need to look at the raw measurements. Our application takes this data and uses it to build a virtual simulation. The user selects a tank from a repository and is redirected to a visual tool. The user can add liquids, toggle moving components, and otherwise simulate a mixing procedure just as they would in real life. This makes analysis simple, intuitive, and doable on any device. Here is our tech stack. We use Unity to develop and support the application, and Microsoft Azure to host our servers and databases. Lastly, we use JavaScript and PHP for data handling. Martin will now give a quick demonstration.
Hi, my name is Marty Place, and I'm going to be giving a short demo of our application. In this demo, I'm going to pretend to be a user who's trying to access a tank from Trumbull, Connecticut. The first step is to log in. Once you log in, you're brought to a page that lists all the tanks in an SQL database. In order to narrow down our search, so we only get tanks that are in Trumbull, Connecticut, we can hit North America, United States, and then Trumbull, Connecticut to specify a geographic location. We can then hit select. Once you hit select, you are brought to a new page that shows a 3D rendering of that specific tank. This 3D rendering is part of a larger Unity application that allows the user to manipulate what is going on inside the tank. For example, you can create a step called Step 1 that adds 40 liters of water to the tank. As you can see, the water level rose inside the tank according to how much we put inside that step. We can also turn the turbines on, turn the sweepers on, and the recirculation loop on. As you can see, the water level went down when we turned the recirculation loop on. This caused warnings to pop up that says the thermometer sensor is not covered by the mixture and the mixture is not in contact with the bottom agitator blade. Warnings like these tell the user whether or not the amount of liquid in the tank allows the tank to be safely used. We also included a change and delete button in order to change and delete steps. Up next is Chris, who's going to talk about how our application pipeline works.
So now I will talk a little bit more about how the application's backend actually works. So once you select a tank from this tank list, it will send the tank ID from our web server to our SQL database. Our SQL database will then search for all the tank information, like what parts go into the tank and how big each part in the tank is. This information then gets sent to our Unity application, which utilizes a tank builder script right here that takes all this information and utilizes Unity prefabs, which are pre-built models of each part, and rescales it appropriately according to the measurements of the tanks and various parts. These prefabs, after being resized, are put into the correct places in the model at runtime for the application. This model will take into account how much space inside each tank is taken up by the various parts. Then, while the user is using the application, the UI controller script works side by side with the tank manager script to update the model according to which steps are added to the step list that the user is creating. And now, Yijiang will talk more about how this project was.
Hello, I am Yijiang, and I will go over the design process of tank visualization. First, we need to have a basic understanding of mixing process inside tank. Then we did our own research and find the most compatible programming languages and tools to develop the application. Since we don't have many experience with the programming languages we use, we spend a lot of time learning them and debug programs. With many tutorials online and help from our sponsor Evan and Professor Shing, we're really happy that we managed to finish the project. We built tank visualization by Unity and host the application on ASP.NET MVC, so multiple users can have access to the application at the same time. We're truly appreciating for the help from our sponsor Evan and Professor Shing. They give us suggestions and support every time we need. Hope you enjoyed the video. Have a good day.